Hello everyone, and welcome to video number 6. In this video, we're going to learn how to solve the remaining indeterminate forms. So in the last video, we finished up implicit differentiation and then started to learn about L'Hopital's rule. At this point, you should be pretty good with implicit differentiation because we spent 2 videos on it. And L'Hopital's rule, it states that if you have a limit of a fraction and that turns out to be of indeterminate form, then you can
It's 10
just
o'clock.
take the derivative of the numerator and the denominator and then solve for that limit. All right, and for some problems, you need to use L'Hopital's rule multiple times to get the answer. And then to solve for the limit of an indeterminate form 0 times infinity, which is just a product of two functions, turn it into this. So f of x times g of x is the same thing as g of x over 1 over f of x. And then for this, you can use L'Hopital's rule. All right, so I have 2 refresher problems on L'Hopital's rule. And if you want to go ahead and do the first one, then pause the video here and give it a try. The answer is first you need to verify the limit is of indeterminate form. All right, just plug in 9 for x, you'll get 0 divided by 0. Okay, so you take the derivative of the numerator and the denominator. So the derivative of the square root of x is 1 over 2 times f of x, or sorry, the square root of x. All right, and then the derivative of the denominator is just 1. Okay, and then you plug in 9 for x, and then the final answer is 1/6. Okay, and here's the second refresher problem. All right, so to solve this problem, you just turn the times x into divided by 1 over x, and then you plug in 0 for x to verify it's of indeterminate form. All right, in the end, you'll get infinity divided by infinity, which is indeterminate, so you can use L'Hopital's rule here. All right, so this is what we had, and you differentiate both the numerator and the denominator. So to solve for the derivative of the numerator, you use the chain rule. The inside function is 1 over x, and the outside function is ln x. So the derivative of ln x is 1 over x, and you replace the x with the inside function 1 over x. All right, and then times the derivative of the inside function, which is negative 1 over x squared. And the derivative of the denominator is also negative 1 over x squared. So these two terms cancel each other out, leaving you with just x. And then if you plug in 0 for x here, you'll get that the final answer is 0. Okay, so now how do you find the limit of exponential functions? For example, here you will have 0 to the power of 0. Here is the process. Just like when you're trying to find the derivative of a function with an exponent, when you're trying to find the limit of an expression with an exponent, the first step is to take the natural log. To keep the expression unchanged, you need to take e to the power of the new value. So if you remember from implicit differentiation, when you're trying to find the derivative of a function with an exponent, the first step was to take the natural log on both sides of the equation. And that's very similar to what you do here. All right, so now going back to our original limit, to solve for that, you first take the natural log of the expression, and then you take e to the power of the new value. All right, so this is the same as this right over here. All right, and then you use the properties of logarithms to move the exponent to the front. And then now you're trying to solve for this limit right over here. All right, to solve for that, you use L'Hopital's rule. So this limit right over here is of the form 0 times infinity. All right, and then to solve for that, you change it into this. And if you plug in 0 for x, you'll find that this is of the form negative infinity over infinity. So you can use L'Hopital's rule right over here. So differentiate both the numerator and the denominator. All right, the derivative of ln x is 1 over x. The derivative of 1 over x is negative 1 over x squared. So after simplifying, that becomes negative x. And then you plug in 0 for x, so you get 0. Okay, so we just solved that this limit right over here is equal to 0. So now we plug it in to our original limit. All right, so this was our original limit, and we got to here, and we determined that this limit, this exponent right over here is equal to 0. So we plug that in, and then we'll get that the final answer is 1. So the limit as 0 approaches 0, as x approaches 0 from above of x to the power of x is equal to 1. All right, so now knowing this process of just taking the natural log and then taking e to the power of the new value, try to solve this limit right over here. All right, so the answer is first you take the natural log and then e to the power of it. Okay, so then you move the exponent to the front. And then now you need to solve for this limit right over here, 1 over x times ln x. That's the same as ln x over x. All right, the limit as x approaches infinity. If you plug in infinity directly, you'll get infinity divided by infinity, which is indeterminate. So you use L'Hopital's rule, and the derivative of ln x is 1 over x. The derivative of x is 1. And then plugging in infinity, you'll get 0. All right, so this limit right over here, ln x over x is equal to 0. So plugging that in, we'll get that the final answer is 1. All right, so here's the second practice problem. The way to solve this. So as always, just take the natural log and then take e to the power of the new value. All right, and then so move the exponent to the front and then turn it into this. So then now using L'Hopital's rule. So first verifying that it's of indeterminate form by plugging in infinity for x. You'll get 0 divided by 0. All right, so L'Hopital's rule. So for the numerator, you use the chain rule to solve for the derivative. And then the denominator, so the derivative of 1 over x is negative 1 over x squared. All right, and then after simplifying, you'll get negative 1 over 1 minus 1 over x. And then plugging in infinity, so you'll get that 1 over infinity is just 0. And then you'll get negative 1 in the end. So this limit right over here is equal to negative 1. All right, and then now going back to our original problem, we plug in that this limit right over here is equal to negative 1. So the final answer is 1 over e, or e to the power of negative 1. All right, and here is the third practice problem. All right, so you just take the natural log and then take e to the power of the new value. All right, and then so we just turn this limit right over here into this. Okay, and then verifying that it's of indeterminate form by plugging in 0 for x, you'll get negative infinity over infinity in the end. So you can use L'Hopital's rule. Okay, so differentiate both the numerator and the denominator. For the numerator, you'd use the chain rule. Okay, and then let's just simplify this a little bit. So we'll move the x squared to the numerator and the sine x to the denominator. Okay, and then now plugging in 0 for x, you'll get 0 divided by 0. And that's still indeterminate, so you can use L'Hopital's rule again. All right, so differentiate both the numerator and the denominator. So for the numerator, you'll use the product rule. So you'll get the derivative of x squared, which is 2x, times cosine x, plus x squared times the derivative of cosine x, which is negative sine x. And then in the denominator, the derivative of sine x is just cosine of x. And then now you plug in 0 for x, and then you'll get 0 in the numerator and 1 in the denominator. So this limit right over here is just equal to 0. All right, so we solved that this limit right over here is equal to 0. So plugging that into our original expression, we'll get e to the power of 0, which is 1. Okay, so now this is the last indeterminate form, infinity minus infinity. And it's a little different from the others because usually you can't use L'Hopital's rule. Okay, so in AP Calculus AB, when you see problems of the indeterminate form infinity minus infinity, they're usually of something like this. So you'll have the square root of something and then minus something. All right, and the way you solve this is to multiply and divide by the conjugate. So the conjugate, you just change the minus sign here to a plus sign. All right, and then you use the difference of squares formula to simplify. So then the square root and the square just cancel each other out. And then 3x squared, that would just be 9x squared. All right, and then after simplifying, the numerator just becomes 6x. And then this is what you have in the denominator. And be careful here because you have a fraction. So your first instinct might be to use L'Hopital's rule, but that's actually inefficient because it will only make things complicated. So the best way to solve this limit right over here is to use algebra. So you want to get rid of the x's. So you multiply the numerator and the denominator by 1 over x. All right, so this x and this x, they are just gone. And then for this term right over here, divided by x. So x is the same thing as the square root of x squared. And then you simplify that. And so this term just becomes the square root of 9 plus 6 over x. All right, and then now you can plug in infinity for x. So you get 6 divided by infinity, that's just 0. And then in the end, you'll get that the final answer is 1. All right, so now using that process, just multiplying and dividing by the conjugate and then using algebra to simplify, try this problem by yourself. All right, so the answer, so first you multiply and divide by the conjugate. You just change this minus sign to a plus sign. And then now you just, so the numerator, you just square x squared, which is x to the power 4, and then square this term right over here. And then after simplifying, the numerator just becomes x squared. And then this is what you have in the denominator. And then you have x squared in the numerator and denominator. So you want to get rid of that using algebra. So you multiply the numerator and the denominator by 1 over x squared. And then now the x squared, they just become 1. And then for this term divided by x squared, first the x and the x squared cancel out to become just divide by x. And then now x is the same as the square root of x squared. All right, and then now simplifying this term, you'll get the square root of 1 minus 1 over x squared. And then plugging in infinity for x, you'll get this is just equal to 0. So the final answer is 1/2. All right, and here's another way to solve limits of the form infinity minus infinity, which is intuition. And now, so this limit right over here seems like a very complicated limit, but if you take a closer look, let's just first switch the orders of these two terms. So the last two terms, let's switch their order. All right, and then now let's focus on this right over here. So we just solved that this limit right over here is 1/2, but even if you didn't know it was 1/2, you'll know that it has to be greater than or equal to 0. That's because we have a -1 in the square root. And if we didn't have this -1, then this would just be the square root of x squared, which is just x, and multiplying that by x, you'll get x squared. So if there wasn't this -1, then this term right over here would be equal to this term. But since we have the -1, we know that this term has to be less than this term. All right, and then since this term right over here is greater than this term, you'll know that the difference between these two has to be greater than or equal to 0. And then on the right side, we still have this limit right over here, which is just infinity. All right, so 1/2 times something positive plus infinity, that is just infinity. So therefore, the limit is equal to infinity. All right, so here are the methods for solving infinity minus infinity. First is multiplying and dividing by the conjugate. You'll need to know this for AP Calculus AB. And then intuition, which you'll probably don't need to know for AP Calculus AB, but it's still good to know it. So now I want to do a summary because one, we're at the halfway point because this is video 6, and two, because in the next video, we're going to start learning about integrals. So we're done with learning about limits and derivatives. We'll still use them, but we've already finished learning everything about them. So I'll do a summary of everything we've learned so far. So we started learning in video 2. We learned the basics of limits and integrals. So evaluating basic limits, this was basically evaluating limits from graphs and using algebra. And then we learned what are derivatives, and then like the derivative of basic functions and the formula for calculating derivatives. And then in the end, you learn the derivative of x to the power of n. And then in video 3, you learned about limits at infinity, and then the number e, which is just the limit as x approaches infinity of the quantity 1 plus 1 over x, and then to the power of x. And then you learned the derivative rules, and then about what are differentials, which is just dy over dx. And here are the derivative rules. And then in video 4, you learned about the derivatives of sine x, cosine x, ln x, and e to the power of x. And then we did some practice problems. And then you started learning about implicit differentiation and how that can be used to differentiate exponential functions. All right, so here are the derivatives of sine x, cosine x, ln x, and e to the power of x. And then in video 5, you continued learning about implicit differentiation. So you learned how to use that to differentiate inverse functions and non-functions. And then you started to learn about L'Hopital's rule. And then now in this video, video 6, you learn how to evaluate the rest of the indeterminate forms. And here are the most important concepts to remember, and it's not a lot. So first, the derivatives of x to the power of n, sine x, cosine x, ln x, and e to the power of x. And then the derivative rules, implicit differentiation, and evaluating limits of indeterminate forms. But yeah, that's basically it. So if you're familiar with all of these, then you're pretty much set for limits and derivatives in AP Calculus AB. But anyway, that's it for this video here. So stay tuned for the next video where we'll start to dive into integrals.